Okay, so here there's a chart to review what we talked about when we graphed on the previous page. You take a look at it. At the bottom, remember we graphed two, I didn't join them up, but they were two parallel lines, so there were no points of intersection. Then we graphed these two lines. They look different, but when you solve for y, they are exactly the same. So they have infinitely many solutions. And we call those lines coincident lines. So that's what we did in that last part here. So the slopes of the lines, if you take a look back, let me see here. So for no solution, they were parallel. So the slopes must be the same or equal. I'll just put equal. Okay. The y-intercepts must be different because they're different lines. And graphically, there will be, so for no solutions, there'll be no intersection point, which means the lines are parallel. So an example would be something like that. Okay. The infinitely many, the slopes of the line must be equal. And the y-intercepts must be equal. They're exactly the same line. Graphically, the lines overlap, which are called coincident lines. So co means together. Incident means they coincide. They're exactly the same line. That's the math word for it. You might even, I always say parallel and coincident. But coincident really means all the points are the same, so it's kind of understood that they're parallel. So that would be just right on top of each other, right? Those are all the same points. And then one solution is just the ones we were doing before, where they intersect in one point. Okay, so the slopes must be different or unequal, I guess you could put, but they must be different. They could be negative reciprocals, they could be both the same sign, but they have to be different values, okay? And graphically, there will be one point of intersection. So remember, we would then write out that point as x, well, whatever it is, I'll call it x1, y1 in our set brackets. Here, we would have the null set, no solutions. And here we would have the equation of the line. I'll just put mx plus b in terms of the actual intersection. Okay, so to graph and solve a system on our calculator, it's pretty easy as long as the equations are solved for y. So when they're solved for y, you can just put them into y equals, okay, on both calculators. So we're going to do that. This gives you the step for the TI. This is for the Casio. And we're going to do that for question number 5. So I'm going to go through the Casio first. Okay. Okay, so you go to your menu for Casio and you go down to graph because you want to graph something, obviously. You clear off any equations. So let's say I had an equation there, okay? So if I want to clear that off, you go up and you press delete, and it says delete formula, yes. It's yes for F1. So press F1 and it's gone, okay? Or you can go up and back delete each term, but that's the faster way. So take a look. Neither of these equations have been solved for y. So we have to do a little bit of work to start. Okay, come on. So here, this one, to get y by itself, I'm just going to add 9 to the other side. So that's going to be my y1. Then for this one, it takes a little bit more work. I'm going to bring the 2x over. So it'll be 3y equals negative 2x plus 5. And then I have to divide by 3, both sides. So this is what you were doing in the last unit. Okay, so that's going to be y equals negative 2/3 x plus 5/3. Okay, whether you have a TI or a Casio, that's what, that has nothing to do with solving it, but both types of calculators need it solved for y. Okay, so go back to y1. I'm going to enter 3x plus 9. So 3x is the x theta t, okay, on the very left. And then, what did I say? Plus 9. So plus 9. EXE on that. Enter on that. And then the next one is negative 2/3. So put in the negative, not subtracting. With the Casio, you actually, for a fraction, need to put brackets. Okay? So, and it will convert it to a fraction. It'll look like dividing first. So 2 divided by 3. Oh, I forgot the bracket. Sorry, just a sec. Let me go back. Delete, delete, delete. Okay, so bracket 2 divide 3, close bracket. Or you could do bracket negative 2 divide 3. Then your x, okay. Then what was the next part? Plus 5. So plus, this one, because there's no x, you don't have to do the bracket. 5 divided by 3. Execute on that, and you'll notice it converts it to fractions. And if it doesn't, that's fine. I can't remember if the other, this is a little bit different model, but if it keeps it as divide button, totally fine. Okay, now we're going to draw F6. So just make sure that your cursor is below there, and F6. For TIs, you press graph. I can see the equations. If your window setting isn't set up correctly, you might not be able to see both lines. So if that's the case, go to window, which is F3. Okay, and you'll see there the third one in standard. Okay, for a TI, you go to window and down to standard. Okay, and then press on that, and it'll convert it to standard, which is negative 10 to positive 10. So we've got that, and then exit on that, and draw again. Okay. Now the thing is, you want to get the exact point of intersection. Sometimes it's nice numbers, sometimes it's decimals, especially for applications. So you want to use the intersect feature. And so for a Casio, it's F5 for G-solve. Solve means you want to find some values, so you press F5, and you'll see there, second from the right, intersect. Okay, or int-sect, which stands for intersection. And so you press F5, and it goes right to it. So it's negative 2, 3. I'll do it with the TIs in a sec. So negative 2, 3. Notice here, when we're showing our work for this, it says x colon with square brackets, some commas in between. That's for your window settings. So we did a standard window, which is negative 10 to positive 10 with a scale of 1 for both x and y. So even though on your calculator it's vertical, we're doing it horizontal on paper to save space. Okay. Now, if you've got a TI, follow along here. I'm going to do the same thing. So on y1, oops, that's not what I wanted. Arrow. So we wanted 3x plus 9. Enter on that. Then we had negative 2 divide 3. In a TI, you don't have to have brackets. It assumes that you're doing that fraction and then multiplying by x. But the newer versions of a TI, so let me finish this off and I'll show you another one, plus 5/3. So plus 5 divide 3. So on a TI, it's not going to convert it to fraction form, but if you wanted instead to go, if you go alpha y equals, these are for the newer versions of the TIs, enter on 1, then it's going to put it in fraction form. So you could put the negative 2 up top over 3, cursor out, oops, just a sec. Oh gosh, sorry, it's doesn't like my, there we go. And then x, you can put the negative up top or out front. And then you can go 5 over 3. So you can do either way. They're both the same. So I don't really care about this one, so I'm just going to go turn it off. It takes a while to get over there. Because that's the equation. Okay, so now I'm going to go to window setting, check. It's from -10 to +10, but if it wasn't, you go to zoom and standard, which is down to number 6, or press 6. Enter on that. Okay, same graphs. To get intersect for a TI, you go second, trace. So that says calculate, and it's intersect, number 5. So either go down or press number 5. And in the TI, you have to do a little bit of work. It asks you, are you on the first curve? And so, yes, it's flashing on one of them, so you press enter. Then it asks, is it flashing on the second curve? You might think, well, that's kind of dumb. There's only 2 curves, right? But you could put in 8 equations, and it needs to know which ones you're finding the intersection for. So second curve, enter, and then guess, which is not really a guess, it's very accurate, but sometimes it's a little bit off to like the nearest 6 decimal places or something like that. In this case, we get the same answer as before, -2, 3. Okay, don't just go trace and estimate going along the graph, because you can see I can't get on -2 here, right? So I can't find that exact point. So you have to use the intersect. And what did that look like? It was through here. And it was up there. So this was the first equation, this was the second with a negative slope, and that point of intersection was -2, 3. Okay, so that's how you can use your calculator. All right, so we're going to stop that.